source, they are moving this capability of the and they have five pattern by see population and one pattern from on different potential she guided she has received from the government. She also received education from the board of the Indian. Madam receives award for the year 2022 by PBTI, PBC, Government Program. Madam received research and external grants minor ICM research for work of 20 lakhs. DSC fund work of 60 lakhs for establishment of gigawatt equipment for IT as quality and figures. PI women development education basically of the technology and India work of 4.8 crores sponsored by the so so very happy
once again, morning to you all. No rest. Am I audible? No answer to the last next. We are here all the experts here in the universities, colleges, teachers. So we understand every candidate who is here, who are listening or not listening, and we see eyes. Okay? I have also inauguration. Now I am this platform do only. These efforts are taken by college for all of you. Try to understand when still in past. I am looking at that. Please. The efforts taken by the college must justify. Whenever I see the students speak themselves, I stop here and try to understand what I saw. Right, ready? Everyone, see. There are two students. Right, I don't take much time. Just I will explain one of the technology started in the profession, which is the implemented in college and research on that. My expertise in that just I share you. And this platform is around collaboration, networking. Definitely our farm. My topic is my slides on science technology that is 3D printing technology. 3D printing technology is being used for the technology of long back. Now we are, it is being integrated in our pharmaceutical professional pharma formulation. First of all, I need such technologies the pharma product. What are the challenges? Of course, the challenges are never ending. We have 19. Unexpected challenges and all our pharma is ready for those challenges and providing the required solutions for those challenges. Hence, we should upgrade our knowledge and we should learn the innovative technologies wherever they started. How can we apply in the pharma profession? Definitely, it is the need. We have not studied all this, but now we are learning. Novel technologies are required for promotion so that we can teach our students. They may become excel in that and may provide the solution to the challenges. Right? And now, this 3D printing technology, why do we use this 3D technology in our what are the challenges? There are basic challenges in all. There is a need to address those challenges by pharma field. For that, one of the technologies, innovative technologies, 3D printing technology to solve those challenges. Some of them, maybe not all, but some of them. How can we solve those challenges? Basic challenges, the solubility, taste, color, etc. Already we have challenges. There are now challenges that is making challenges. A complex dosage regimen and there will be various in the response to those drugs. The two common challenges, major, I can say challenges, need more addressing challenges. For that, a delivery system called personalized or customized drug delivery system. For that, customized or personalized delivery system, the one of the technology invented is 3D printing technology. Why the need for customized delivery or personalized delivery? Because all the patients show the same response to the drugs. There are not variations for the responses. Because of that, there are again adverse effects, toxic reactions. These are essential immediately, and which is followed by us with some technologies. And that subject is the variations in the drug response by the genetic variations called pharmacogenetic. Because of this genetic variations, there are changes both pharmacokinetic or dynamic reactions by the particle. We have seen the old observation is imaginary. And some of the patients have more like this, but some of them are not shown. Why? The reason is the problem in the enzyme capacity or the deficiency in a particular patient. Hence, such patient get separated and we require a customized system. And there are 120 drugs, including these are all drugs whose these are labeled by FDA required pharmaceutical discoveries. The major reason for the changes in the pharmacokinetic and dynamic behavior of the drugs in the particular patients is due to the enzymes involved in their position or metabolism. Cytochrome is the major class which involves the biotransfer of drugs because these drugs are all exogenous substances once enter into the body. Definitely, the body tries to eliminate by different mechanisms. One of them is the metabolism and enzyme the enzymes. There are different classes of enzymes also. Each enzyme has its own specificity to act at a particular site of the enzyme to make or break small forms which can be easily eliminated. So, among all the enzymes are there in the biological system, human body. And among all the people may not have the same capacity to produce Those agents do not have the same quality of the agents. Their ability to metabolize may also be different. That's what we have to old example demanding. So because of this, there is a changes in the variations in the patient's responses to the given drugs. These are all some of the examples of the exogenous and endogenous factors which shows differences in the drug responses. Both pharmacokinetic and pharmacodynamic variations we may see in different patients differently that we are calling as genetic polymorphism. This genetic polymorphism, about 99.9% of same genes may be present in all the individuals, but that only 0.1% difference in the genes also leading to changes in the responses and that is a lot of trouble to us to develop different types of the derivatives and those forms. We have seen biopharmaceutics, this polymer section from polymer. There are people who can accelerate the fast, rapid, but there are people who cannot. So when the process of accelerating is slow, the slow state, they cannot metabolize the drug, which are thus in the presence of the large one for large time toxic. Hence, the need of the farmers now. How can we solve these problems? Yes, we can do by different forms of the by making personalized for a dresses, tailored dresses, where we take the dress which is completely confined to you and which is fit to the particular person. Here also the medicines can be developed which are exactly fitted to a particular patient. So that is nothing but the personalized medicine or customized drug delivery system, which are also called tailored drug delivery systems. Now we can see the what is personalized medicine, which is nothing but a medicine given to the right patient with the right drug and the right at the right time in a right dose. So these can be achieved only with a special focus development systems to a specific class of patients. They cannot say for all the patients. So we need to provide special dosage forms for patients to avoid the adverse toxic effects. It is also because tailoring the dosage form or the delivery system to a particular patient based on the need of that particular patient. Maybe the delivery, the dose or maybe drugs maybe different patients or same disease. That's what I do. You have seen the all of them have not similar. Some of them drastic on the spot diet. Some of them with staggered health challenge. What would be the reason? Stand on that the reason what would be? Yes, definitely people are different in their capacity to stand also similarly response. So definitely now there is a need for development of personalized delivery. Now it's gone, it's gone the traditional delivery systems which are helping my all the patients uniformly. It's not now. Now we need to develop individual tailored medicines for individual patients. Yeah, we have to do for the individual patient and their behavior, their capacity to biotransport, to metabolize, etc. personalized delivery systems. Yes, developing customized medicines, we must have an understanding of the patient genetics and also different behavior of the patient molecules. Now the trend is do not worry about getting the new molecules for the disease. Whatever the molecules we have, should be given the right patient, right one. That is the major goal now. So such new molecule. This is also the system helps us to create light reactions, improve the efficacy of efficacy of the drugs and development and different examples where they go on this. There are some yes, in the cardiovascular diseases, cancer, the breast cancer, more involved in to. So if you find out that to protein involved, you may not know breast cancer. Few patients from the breast cancer involved in this. So by keeping point in mind, you have developed a system suitable for that particular disease. That becomes again for studies and the clinical bias going on. And even the cardiovascular diseases, whether on the cardiovascular clinical trials were. So that's and all that identify and diagnose the diseases customized to diagnostic agents. And for that, instead of suppose traditional dosage or formulation, we can develop the bulk quantities, batch wise and supplying to the patients in the change process. But when a particular patient, a group of patients required, we not to provide that much big batch of formulations, we need to provide small scale and sometimes small quantities. So there, this creativity technology helps us to provide the small scale whenever required, whatever patient required can be created and can be supplied to the needed patients. What is this technology? It is in other applications now in the medical field of medical science. And I mentioned that revolutionary technology for pharmaceutical applications. The term is defined as fabrication of objects through the deposition of material using print head, nozzle, and other technology. We know very well printer where we are using in our regular purpose. Whatever the matter of type is the software that you are print out on the paper. Isn't it? So now you can print tablets of formulation where you can feed the matter software or type of information required. What is the dimensions of that? What is the dose to be formulated? And how it should be released based on that, the total idea, the total required dimensions of characteristics of the formulation can be fed into the software. And then once it's fed in the software, if you put on print like that, which we are doing regularly, but this printer is different from that printer. It is a 3D printer where we can see X, Y, Z axis also. Where we are seeing on the paper it's dimension. But now we are going to see three-dimensional. A tablet can be printed. A rings, a patches, all these can be printed with this software and where we know very well you have typed, you have read it, your hand and checked, and you type it and get many corrections easily and final printout can be taken. Isn't it? That's what we are saying in the printing. Now here also, once you have fed all the characteristics of the formulation in the software, then you can have a printout of a formulation. If you find anything mistake or any error in that, so we are going to get 2 or 3 formulations. If you have found any, then you do When you do the evaluation, if you find any test or failure, you can change the characteristics in the printer itself, the software itself. Then again you can get. There is no much loss of the time and no much loss of the material also. By that you can get the exact up-to-date formulation just by getting print out of the formulation with the software. So I think you can appreciate this technology for the foundation development, which helps for the avoiding the number of risks and also what do you say toxic effects the patients, both towards the manufacturing side and from the patient side and being a pharmacist. We all will have more comfortable with celebrating technology when you compare with the traditional technologies. Hence, this helps us to avoid number of errors and risks. This how it works. Let us see. I have given brief concept. I have given a brief concept about it. Just to see the structure. What in this? What are different methods are there? How it works? We see the ink in the printer. Have you seen ink in the printer? The general printer which we are using for our printing purpose of papers. There is a ink accepted. So that ink will be our formulation, our ingredients, drugs, polymers, excipients will make an ink. That ink with the tablet by just printing. You will not do anything. Whatever is required can fit in the software. Now, what are the steps involved? I go ahead briefly. The three-dimensional printing process in which structure previously prototyped in software, that is previously built in the software, is fabricated into the structure layer by layer. Slowly, it brings layer by layer. You might have seen some of the articles, some of the items, some of the toys are printed by the 3D printing you might have seen. To know which structures, what structures should be gained after printing, we will get the dimensions, length, height, thickness, and the gaps between the two layers. Everything will be fit into the software. Same structure will be printed on the platform. That is going to be obtained. Where we see the tablets or whatever the patches we are doing, it will be taking about half an hour to 1 hour. But when you see the toys, I have seen a 3D printer idol of Lord Vinayaka, which is somewhat this size. It took about 24 hours to 48 hours to print. What I need to say here, this printing at a time will not come to total structure. Slowly prints as layer by layer and does it get whatever the structure we have expected in the software. So that structure will be obtained here. It will not be at a time, will not produce directly, it is going to print slowly. That's why it is also called layer by layer printing or additive printing. And this technology I have given here additive manufacturing or rapid prototyping or subtracting process. All this involves the layer by layer and also removing the methods or any other technologies or text speech for really cutting all this will be taken care about this all this taken care by the printer. 3D printers are used to create a wide range of products including toys, foods, jewelry, automobile parts, aircraft. Now we can have our own formulations using different biopolymers, bioglass, or bioceramics. What is the step involved? Steps involved this or these. What we do, what is the model or what is the shape or what the quantity in each formulation will be decided based on our previous research. And then it will be whatever required will be given in the software, and that will be converted into a language file which can be read by the printer. So that language, the matter which we have given is converted into a language which can be easily accommodated in the printer or compatible with the printer. Then that will be accepted for the transfer of this our software into the printer. Once converted to this language, This file stores the information for all the three surfaces, whatever the 3D model we require, whatever is the form, whatever the structure we require, and that 3D printer enters the STL file, the language file, and convert the file into another file, which will be via slide method, via layer and layer, will be present in the 3D printer. And this file finally makes the sequence of 2D cross sections and also the 3D printing object. This is going to be taken place. Designing using a computer-aided software and converted it to the 3D printer readable language, then processing the material. We have done all this in the computer. Now we have to make the material, process the material separately. What are to be included in the formulation? Maybe the excipients, drug, polymers, etc. will process all, mix all the ingredients, and that will be taken into the printer. Okay? Information we have given in this computer, and for the 3D printer, the total formulation filled is ink of the 3D printer. Once the directions are given, this formulation will be printed and can be taken out. After taking the formulation, maybe a tablet or maybe a scaffold, whatever it is, we will get that post-process. Processing, pre-processing, processing, and post-processing, where we have to use the drying of this and further packaging, etc. Object that is nothing but the formulation. Yes, the basic concept is that one. And based on the material used, based on the shapes, based on the characteristics of the material and quantity, etc., various 3D printing technologies are there. Based on the metal asset, the liquid, some technology, semi-solid, some technology, solid, and the powder. 3D printing technologies are there based on the liquid solidification or extrusion based technology is used for the solid, for semi-solid, and for powder different technologies are there. So in this again different type of the technologies and the printers are different here. Technologies in the printer mechanism based on the formulation, based on the materials you are using. I quickly go ahead with the different printers. I don't discuss more about the technology of this, but for what type of the materials can be used. This is a FDM technology which is called fusion deposition modeling, where we take the thermal energy and we whatever the material. Whatever the material we have taken, that material should be stable to the temperature. Or it is going to be exposed to the high temperature, thermal energy, where it mixes all ingredients and converts to the liquid, and that just like a liquid printer, that will form a film that is drawn layer by layer according to the design we have given, the shape we have given. But only thing is the material should be stable to the high temperature because it is exposed to the thermal energy. That's what I can say here. You can see here how it is printing the tablet layer by layer. This the total shape and quantity and everything you have given the so that according to that we print the formulation. Like this we can print layer by layer blocks. Because there are some blocks can be given or needed to give some patients formulation. Instead of giving 2 to 3 tablets, we can make a single tablet of formulation by printing in different layers. And first one drug, then upon that again the layers are printed on that and single tablet, which is very convenient to the geriatric patients. You can understand why they are using that. Next is the inkjet printing. You can see here, this inkjet printing is ink is on the platform. It's on demand or continuously on the platform based on the dimension and makes some pages for the tablet line. Only here you have to see the viscosity, the ink material is important. What is the viscosity of the material? That viscosity decides the size, shape of these formulations when to the printing. right? Next, we can see the stereolithography, where we are using the UV light. This UV light turn the liquid into the solid. Okay, now what we do here, the total formulation which is printed is kept as which undergoes qualification based on tank like structure. Now the UV light is exposing onto the liquid. That liquid will be converted to the solid based on the light exposure. The light rays are reaching the liquid. That is designed the shape of a formulation, size and shape of a formulation. So previously the material is, the material is used as a ink there, and that is it. But here the material is based on the only the light. The light is exposing onto that exposure of the light varies. That depends on the shape we have fit. We have given instructions to the software. That shape can be obtained because when the material is there, the tank of that form. And when it is exposed to the UV light, it is certified according to the dimensions we have given. That size of solid size of formulation can be obtained. Next is this is also powder printing, and it is similar. Next one, just like the selective laser printing. In previous one, we have seen the UV light. Here we use the laser beam. This high power laser beam is used to filter the small particles of the polymer. Look into this. The particles of the powder is filled in this continuously, and the laser beam is exposing onto this, and that taking into the fabrication of desired shape is getting. And like this, variety of printing technologies are there, whichever the material, based on the material and status, you can choose, and you can get the desired shapes and sizes of the formulations. And with the mixture of complex transforms, we can get the single formulation. And apart from the formulation, this printing technology can also be used for the printing of prosthetics or the organs or tissues. Like suppose here I have given these printers are used for the bones can be printed here. You know very well the size of the bone or the dimensions of the bone, or even the organs also, legs, hands, fingers. What happens, it will be different for different patients, different persons. So you can't manufacture all the legs or fingers or hands separately and you can't use. So you can take the type of particular patient. And those dimensions can be taken and can be as instructions to the software. And based on that, we can get organs or the bones or the tissues we can also be printed here. That is bioprinting of the tissues can be obtained. And this you can see the bone tissue printing, where you have to implement, you have to incorporate what type of the materials are required for the bone. You know very well what tissue has what type of the materials, proteins, enzymes, or the cells required, what type of the growth cells, growth factors required. We know the knowledge about the physiology of the total body. Once you have the knowledge, you can those materials for a printing of a particular organ. You don't have to worry about the composition of the organ because we have the knowledge and it is well known to the total world. What is the composition of the bone? What is the composition of teeth, finger, nail? So once you know, you can procure all the material required for that, and according to the need of the person, those dimensions can be printed by incorporating all those materials in the ink or printing material. Like that, you can print any type of the tissues or organs. So with this, we can understand easily the advantages of 3D printing technology. These are the advantages I have already mentioned. I focus on actually what I did. So I go ahead fast. There is a better resolution, accuracy, more reliability, and infinite type of the dosage forms can be prepared with this. Customized drug delivery systems can be made. On demand, you can prepare. You not prepare it early and you will not wait for the someone to come and take your product. You not worry. On demand, you can prepare personalized medicine and rapidly you can prepare all these are
eco-friendly and the risk is very less. We are not wasting any material or time, etc. But this, whenever there is a need, then we are doing all this. And efficiency is good for this. And these are some of the dosage forms developed by the 3D printing. Oral dosage forms, you can see the tablets and pellets. There is a first oral developed that is the Zipdo, which is an oral dispersible tablet was developed and patented, I mean, approved with FDA. So other skin vaginal formulations are parental dosage forms are also prepared by 3D printing. And topical dosage forms are also prepared. Like this, we can print a number of dosage forms in this 3D printing technology, and thus you can apply this 3D printing technology as a unique application for different problems or challenges. And I have given one example there, you can use the complex drug release because a patient required one drug and immediate release, another drug sustained release. But now what are they doing? They are getting two different tablets. No need for that. You can develop a sustained release tablet again. You can give a layer of immediate release drug that the patient will be more comfortable by taking a single formulation. Like this, you can get issues, everything can be obtained. And this is the example I have given Jimdo's technology where they could develop a oral disposable tablet fast. These are some of the formulations developed by the 3D printing technology. As we are had the time going fast for any clarification I will be there. And these areas are all diseases, all patients can be benefited with this technology. This is another technology, I mean another example. This is another example where in the hospital itself they can build a wing that is 3D printing, where the doctor diagnoses the disease and the quantity of the dose required for a particular, especially for pediatric patients. Required immediately, digitally, non-digital can be transferred to the pharmacist, where the pharmacist can establish the 3D printing technology and whatever the requirements given by the prescription of the doctor, then instructions can be given to the printer and the material can be ready for all types of the diseases and all the types of the drugs, and that material can be immediately fed into the ink, the printer, and you can get it printed. So like this, total online, you can get the formulation to the patient immediately. This setup is also can be useful for personalized dosing or variations in the drug doses, etc. This is the example I have given now. And there are, of course, everything has both sides of the coin. Disadvantages or there. Only there is a disadvantages. Technology update. Can you do now 3D printing technology? You have to update your knowledge. Every time the technologies should be updated and the software should be updated. There will be corruption of software every now. There will be changes in the software. So viral now this what you say antiviral. We are using antivirus for virus creation. The software, what happens, software will be damaged, you have to update it like this. You have to do all these things. Cyber risk, that's what I said. The regulatory issues are also there. These are some of the other challenges. Every time the operating process will be needed to change to some extent based on the material printing or based on the characteristics of these materials. So I can conclude that this is a silent revolution in the field of pharmaceutical technology. Just I would like to say some research we have done in our laboratory 3D printing technology. 3D printing technology, 3D printer is not easy to purchase, it is very costly. Of course, there are funding we can purchase as we could not purchase, but what we have is just I'll give one example where everyone can afford for this. With the help of engineering faculty, mechanical engineering faculty, we have accepted this printer and we have used and we are doing work on them and successfully we have got a number of combinations. Especially we are working on the skin tissue engineering for developing the scaffolds, for reading the wounds, burn wounds and other wounds, accidental wounds, etc. Because these wounds are treating so far by some labs or some ointments, some combinations which are not successful and there are a lot of problems with those, especially in the case of chronic wounds, diabetic wounds and burn wounds. There is a need for the development of these scaffolds for applying on that. So what we are doing, we are developing a skin tissue, simulated skin tissue to apply on the wounds for treating it fast. And the materials which can be used are number of biopolymers, we are collagen, gelatin, alginates, fibril, etc. We are using incorporating some cells, keratinocytes, etc. One of the starters which we prepared using the design of experiment is these are the different combinations we have used, and a pre-processing process, three steps will be there in the 3D printing technology. Pre-processing, where we are giving instructions to the software and we are preparing a formulation or total material composition, and processing, where we are asking the printer to print out. Next, post-processing, we are taking it to pack, dry it and pack. So this is the 3D printer we have, and we have developed the, as I mentioned, the scaffolds which can be applied on the goods. You can see here, there's a video actually. Get the video. There's a video here. Yeah, this is great. So it is the materials which is going to be used as ink is filled in the cartridge. And here I have filled in the cartridge, and in the software, in the computer, I have given instruction. I fixed the cartridge to the printer. Now the printer, with the help of a nozzle, it is printing layer by layer, and also for each and every line, gap can also the gaps can also be defined by us. What I mean to say, accurately, whatever you need can be obtained by the 3D printer. Okay, again, this was tested for the in vitro test and vivo test. That was prepared with one of the waste product that is expired dated by state we have used as a API or as a ingredient which has the good capacity to for the angiogenesis. Then we have analyzed these for different in vitro, chemical, morphological, mechanical, and even the environment studies company. And of course, these are the results. And we have applied DOE to optimize the composition for the best scaffold. And after that, we have found this, compatibility with the stats also we have done. And animal studies we have done. And finally, we developed a scaffold which was successfully healed the wound in the rats faster than other products, market products which we have compared. These are some of the articles published recently on 3D printing technology and products developed by 3D printing technology. And also we filed the patents for this. That I got grant also. The grant. And some of the funds also we received for this skin tissue engineering and 3D printing, like SMR for skin tissue engineering, and for 3D printing especially we got DSTV funds as a prototype development. And recently for the same product, everything value this paper. And these are some of other products we have developed by 3D printing technology, but this was developed with not our 3D printer which we have used, but with a collaborator, CSR, CEI, Karakudi, their 3D printer, and with that we have done this scaffold. And when you see these scaffolds prepared and in follow the structure, you can see that the apertures or the gaps, these are essential, the size and dimensions are essential for growth when we apply on that. Yeah, these are the other. And just I would like to say here, this is the traditional method we have done, the scaffolds by the sandwich forms as to with that. These are prepared with 3D printing, and then 3D printed, when you see the stability studies, 3D printed products are more stable and are not changing their morphological structure. Yeah, this is a small attempt for presenting the novel technology and pharmaceutical sciences, which may be useful to the young budding pharmacists here to explore this technology for further foundations courses. And just like that, as we are discussing about the innovation, now the trend is gone getting marks, scorecard, and some publications, etc. Now the total country is watching at the job creators, not for the job seekers. Especially you people today, our vice chancellor mentioned about the coming country totally the young country. The total country becoming young, why? Because you are going to lead the country in the next 10 years. So you must be at the stage of job creators, not the job seekers. For that, you need to think about the innovations, innovative technologies, to apply your knowledge and the challenges you are going to face day to day. So that helps to get the innovative technologies, helps for the society. Then you can start your own enterprise and you can lead your total business. You can create jobs. So for that purpose, all the educational institutions, I hope you all have IIC Institutional Innovation Council. I think you have that. Total Ministry of Education mandate is in every institution because we have to inculcate the innovation technology to all the students along with our subjects and knowledge. That is more essential for you. When you have any innovative knowledge or innovative idea, how to implement it, how to work on that idea, which may not be related to your subject, which may not be related to college, but you want to work on that idea. Where do you go? Yes, there are some centers called incubation centers are available in the country. Similarly, in our university also we have incubation center. In Andhra University also there is an incubation center where you can approach with your idea and you can do work on that idea in that facility. Then you can get your product from your idea, which will be further can be developed commercial. Okay, and that's what you must know that there are incubation centers in the country where you can go. It is irrespective of your marks, pass percentage, or your subject. Only based on your idea, which can be scalable commercially for the society. So for that, there are incubation center, and this is one of our incubation centers started in our university, which is funded by that. Just I go ahead with the instruments available. There are sophisticated instruments, especially GCMS and HPS are available. And we are mentoring in different areas of ideas, or those are the idea, I mean, area, trust areas. And we are also providing the facilities for them in our incubation facility. Apart from the working facility, we also have some instrumentation facilities, common instrumentations and GCMS. All the labs are available. You can come at any time and you can work on that. Anything is there will be a minimum charges you have to pay. That's all. They're all available in our. We also do trainings for the students, etc. And with this collective efforts, maybe through our teachings or maybe inspiring our outcomes or anything may inspire you for the benefit of local samastha local. I thank once again the organizing committee, college principal, secretary for inviting to share my knowledge with these young pharmacists to gain knowledge from other experts who have come here to enlighten you people. Thank you very much, and I hope any one of you can go ahead and you can explore. We can give a, you can plant a seed in your mind. You have to grow it, you have to nurture it with your own efforts. Once again, thank you.
Students, you have anything else? Students, researchers. I take this opportunity to convey many sense of thanks to my everyone. Principal, Organizing Secretary, Nirmala Pharmacy, for providing a wonderful opportunity to me as a chairperson of this session. I feel really happy and honored to be the chairperson of the session of this wonderful session. Madam has explained very well regarding this credibility, which is currently very required to the business community as well as the patient need. I strongly hope the subject, the topic what Madam has covered definitely will be useful to the student community and researchers to take your research to the next level. So Madam has covered from the basic level to the advanced level what Madam has did in her laboratory, in her college. So we can now say thank you, Madam, for giving such a wonderful presentation. So thank you very much, Madam. Thank you, each and everyone, for giving me this wonderful opportunity. Thank you. Any questions? Would you like to take this?
Very good afternoon, ma'am. The session has been implemented, ma'am. The importance of 3D printing technology, 3D metabolic as well as audio and visuals, in order to avoid the possible adverse effects and prevent the therapeutic benefit. The session has been implemented, ma'am. Actually, we are fully blessed to have you in this, ma'am. And dear students, if you have any doubts, please feel free to raise your questions. I'm here to clarify your doubts. The session is best and the session is interactive. The session is interactive. Plus, anyone having doubts, please feel free and raise your questions. Thank you.
First and foremost, we express our deepest gratitude to our eminent resource person, Professor M. Vidyavati ma'am, for an enlightening and thought-provoking session.
As a token of gratitude, we now request the dignitaries to kindly felicitate our honorable resource person, Professor M. Vidyavati ma'am.
I request all the dignitaries and HODs, please join us on the I request the dignitaries and the HODs, please join us for the felicitation. Let's give a big round of applause. చేరి వెళ్ళిపోయాను. A sincere thanks to our chairperson, Dr. B. Thangabalan sir. Your presence added depth and stature to the session, and we are truly grateful.
May I request our chairperson, Dr. M. B. Thangabalan sir, to kindly accept the token of gratitude from our dignitaries.
I request all the dignitaries please stay back for the felicitation of our chairperson, Dr. B. Thangabalan sir. Let's give a big round of applause. We are especially grateful to our co-chair person, V.L. Anusha, for presiding over the session and for offering valuable insights.
As a token of gratitude, we request that the dignitaries to be reaching for co-chairperson, V. Anusha.
I request all the executives and HODs please stay back and join us for the felicitation.
Second group.
To the next session of today's next.
International.
Let's move on to the
Session 2.
session. Chair and please.
Jarag.
Let us go on with the session. It is now my privilege to introduce our esteemed co-chairperson for this session, P. Manoj Karnavai, Associate Professor, Faculty of Pharmacy and Analysis. And now respectfully invite Professor P. Manoj Karnavai to kindly join the session and give the proceedings.
We are deeply honored to have you with us. We look forward to valuable guidance during the session.
Good morning to all. Secretaries, introduce the chairperson of the session, Dr. P. Sajul sir, from Several Organizations of Pharmaceutical Sciences. Sir has completed his B.Pharmacy, Vishnu College of Pharmacy, and he completed his M.Pharmacy from Azharanagar University, and Sir has completed his PhD in the year 2020 from Azharanagar University, and Sir has teaching experience a total of 12 years. And Sir has published many national and international journals in Scopus Index journals. Sir has published many patents. And Sir has added so many projects for B.Com students, M.Com students. And Sir has attended as chairperson and co-chairperson in many international seminars. And Sir has awarded with University Grants Commission Rajiv Gandhi National Fellowship to pursue his PhD degree for the year 2013 to 14. And Sir has topped his PhD examination. Sir has been paper evaluator for PG and UG pharmacy courses from different universities. And Sir has been an external examiner for Azharanagar University. It's a privilege to introduce the chairperson, Dr. P. Sajul sir, on the stage to invite the speaker for the session. Thank you.
is a very good of to Canada. First of all, I would like to sincere thanks to management and principal organizations we are College of Pharmacy for inviting me so as a chairperson for today's international symposium, sustainable practicing innovative nanoparticle development, voting on technology transfer. And it's my great privilege to introduce second IFS section. Speaker is Dr. Chandraya. Sir, currently working as Associate Professor at Department of Biological Science, NIPA, Hyderabad. Sir completed his B.Pharmacy from University College of Pharmaceutical Sciences, Kalahari University, and his MSc and PhD from NIPA, the Department of Pharmacology and Toxicology. Sir completed his postdoc, Florida, AMD from University, USA. Sir received 70 research projects, that is total of 30.6 scores. That is very great. Recently, sir received ICMR recommended research project, that is worth of 3.6 scores. Okay. And sir published one US grant patent and 9 Indian patents. Sir published more than 200 publications in his national international journals. In reputed journal Corpus, Science Direct, Elsevier and Science Direct. And sir published books and book chapters around 9. And sir received various awards. Okay, that is more than 15. Okay, sir is also probably before that. Sir, just give 2 minutes introduction. This is very short brief introduction of Dr. Chandraya Guru. Sir, please come out of the desk to deliver the presentation. Thank you. Sir, thank you very much for introduction. I will start up the time. And I know you're all hungry, I'm also hungry, and let's have the session to go for. So, quickly going into the session, and before that, I want to thank management of the Nirmala Pharmacy, sisters, both sisters, principal of the college, and Dr. Rai, the chairperson, both chairperson, the department stories, as well as students, and ignorant academic students. So, here I'm going to talk to you not to the faculty, right? So we can I want to only talk to the students, not to the faculty. They have to do that. So this is my I think pharmaceutical innovations that I have why we have to talk pharmaceutical innovations, because India is pharmaceutical capital of the world, but not in the innovations. Only pharmaceutical capital of the world, the volume, not the value. Let's say volume and value is big, right? Volume in the sense you can produce it in a lot of quantity, but no value is very less. Right? The paracetamol value is only maximum 10 rupees. Whereas a monoclonal antibody can be lakhs, or injection can be lakhs, few lakhs. That's the difference between the value and volume. So we are really lacking in the innovations for the. And if we don't actually catch up the innovations, we will keep on polluting our India with a lot of drugs, a lot of APIs, so producing now volume and the volume. Today, in the era of the AML, anything different. Can you make the new products? Can you make the new drugs, new formulations here? Kind of talent India has, number of pharmaceuticals now. We are really lacking in the innovation. We are okay to copy, we are okay to produce something and produce to somebody. but not in the university. We all have to think differently. As a faculty, we are certain limitations. As a student, as a BPharm student, as a MPharm student, a pharmacy student, can't do think. Now we have everybody talking to AML. The field is, surrounding around the AML. Thank you. Every field is surrounded by the AML. What is AML? Do you think AML can be part of our pharmaceutical sciences? Do you think? Really? Where do you think you can have AML in our pharmaceutical sciences? Can you apply in the API production? Can you apply in the discovery? Can you apply in the clinical banks? Every field can be applied. You can actually predict that track index is better than AML. We have hundreds of thousands of drugs. What kind of combination? I was talking about pharmacogenetics. What patients should take what drug? All you will decide based on genetic type. We will not remember each and everything. Doctor will not remember one of them. AML can actually predict it. Okay, with this particular genetic makeup, this combination can be solution. With this particular level function, this can be solution. You can answer any symptoms. This is the power of the AML. So, India being a superpower in the engineering technology, we take a software capital and software capital. That means we are good in the AML. If we are good in the AML, if we are the capital of the pharma capital of the world, why we cannot do the innovations? Don't have to think about it. That's where we have to go. Different thought, innovations only good as a developed country. Now, you keep on noticing the volumes, not what happens, right? In this context, we just want to talk about some of the practical opportunities what we can have in the pharmaceutical area and how you can apply that area, right? This is what my question is. We all know that this stuff is very risky. It takes 12 years of time and 2 billion dollars. 2 billion is equal to 1.8,000 crores of this. Who's going to pay 8,000 crores of this? Actually, I can pay and close year. You have spent 12 years of time. Not one. How many people have worked for one time? 10,000 people minimum, 10,000 different scientists have to work to bring one time. After very slowly we come to know that that is successful or not. Who is going to take this test? And success is less than 1%. Less than 1%. That's why India is not able to afford that discovery program. So that's why each and every pharma company is safe in the sense, more risk, only a little benefit. If you have take more risk, there will be more pain. Since we cannot afford high risk, we are actually taking a very slight benefit. Despite our having excellent manpower, the country. Just how many people are there? More than 200. Even 5% of people are getting inspired. What can be thought differently? How much we can produce innovations? Innovations come only from the right mindset, not from us. Because you think differently. First, you may think out of the box. You cannot always think out of the box. Just don't stick to your textbook. Textbook is fine to have basics. Without basics, can you think it? That's what you should. Right? The drug can come from different sources. Initially, we are getting the drugs from which source? Plants. Or the anti-toxic drugs. The antibiotics might have come from next source. Now we have drugs coming from biologics. The cells microbes, and you are also getting access from the antibiotics. And we can also think of repurposing the drugs. Repurpose in the sense, use the approved drug of some other. So this is what I can say. Take that kind of approach for us to do. During COVID, we have been using primarily chloroquine, we have been using for COVID therapy. How much we have made, claim that India can produce drugs to test or just chloroquine, just sending chloroquine and this will get a lot of pain, right? Along with accidents, right? How many people know that this is what is that discovery? What is development? And if that is stuff, then it's not development. Why you have done that discovery and development? Is there a difference? Okay. Is there a difference between that discovery and development? When up to what stage you can discover? Up to what stage? You discover in the sunlight, you identify the target, like a 3 protein complex or any engine, which are your targets, right? and you try to develop a new molecule. New molecule means statistic also, but first time try anything particular target. It can not mean that right. The next important concept is the because finding to this knowledge. Right. Similarly, you can have identify that small other new molecules to attack or target surveillance. This is what it will target. So, upon animal strategy, proving success, doing animal studies, doing cell culture studies, doing also targeted studies is called not discovery. Now, what's the development? Development is about proving safety. More than efficacy, safety is very, very important. If you don't prove the safety of the drug, it will fail in 50 years. What happened to the company is that 5 years on a molecule. If I'm not, then actually even another priority the safety. But when you what you have to do? You have to start again at zero. Who's going to account paying some funding, paying your salaries and building construction, this kind of thing, just working on it like that. Whereas academic institutes like us can think that what I'm losing, we are actually going for a master's and PhD program for people. And the fact that there are actually well qualified, they are PhDs. Why we should not? There are some undergraduates, right? If I can get 10 crores of grant from ICFR and different funding agencies, you can have good concept, always funding. And another is also clearly talking about incubation. Don't look for jobs. Look for job, provider, not no more student PA. Always job seekers, job provider. Needs start up background work. It can't just become a job seeker, a job provider tomorrow. It should start B.Pharm level, it should start Pharm level, and it should keep on maturing till a master's and PhD. That's when you can actually have your own startup to building. I know. Growing, that should be your way of doing, right? So, discover, drug discovery, people start screening trials, review and approval, and phase what so many phases are there. As a pharmacy student, where do you play a role? Where do you play a role? Everywhere you play, right? And one person, they will do anything. All right. So, wherever you think can be done, you do. And in all these different stages, AML can be applied. We mentioned colleagues, right? Can you reduce the time? We can bring colleagues to 5 years. It's a lot of concept, right? If you can reduce the cost from 2 billion to less than 1, even you don't want to reduce the cost, you fine. But you need to, improve the success rate. That's what you should be doing. Different stages of the contestant of the target validation, lead accumulation, clinical testing, Google Analytics, and Google. If you see 10,000 molecules have start to get on 10,000 to 20,000 different molecules have start, and we have one drug that's successful. How many molecules will be 10,000 to 20,000 different new chemicals? Who's going to synthesize molecules? Chemistry. One chemical reaction takes 1 day for you to complete it. Now, person has to synthesize 10,000 molecules. Is it possible? It's possible. That's the start of time. Then you get only one price. How the molecules are getting built from 10,000 we are getting to 50 molecules. Means the molecules are not active on the scale. And so from there, in animals, we will be having 5 molecules. So if you can understand the efficacy of the safety, then you understand whether it's active or not, whether it's safer or not. Both needs to meet your requirement. Then what are molecules is safer and active will be going to the clinical trials. Again, clinical trials are phase 1, phase 2, phase 3, phase 4. Phase 4 is nothing but a post-market surveillance. Even that can be looked up on the market. And you give the example, it can be looked up on the market, couple of example of those. But that's definitely right. One example, drug has been looked up on the market, couple of those. Couple of on the market after approval. An example is think about it. Lot of drugs have been looked up on the market. Drug is never be enjoying its support status unless you improve its efficacy. Until you improve its safety, that's why the pharmacovigilance has the post market surveillance. Improve its safety and efficacy. That's must even paracetamol also. Tomorrow you come up with a new Same becomes in the parasigma. There is section of scientists might claim that this time is we should stop because now we have identified a new problem. So we need to scientifically validate, right? No drug is safer until unless you develop such safety data from the pets or clinical utilization. See, complex sections are there here. Every section is important for us. You might have studied all different areas during your first year, second year, third year, fourth year, whatever. Right? I will not study some of them, not this particular different analysis, essays, cellular and technical targets, genomics, proteins. Very, very common. Obesity is very common nowadays. So they are kind of covered in your studies. What you have to learn, you need to understand basics. From the basics, now put AML experts. Can come together and try to design a new model. That should be all about. See, different states are there. Time to explain, you try to see the compound active or not. The compound is active, go to next stage. The compound is not active. You can go to stage 1. So it's people forward, backward will be happening. So if there is a very good chance that the molecule, after going certain steps, there is a concern there, can come back. How to overcome this? What you want to come back from the not progressing to the next step? What is the reason? It is not meeting the requirement. Meet the requirement of dose may be proper. It's not observing from the body any problem. It may be not staying in the body, or it may be having some kind of interaction with the body, right? So what do we do then? That okay, this step cannot be taken further. That will stop it. 5 years of time spent on that is wasted. And hundreds of thousands of people are working that project. Who is going to approximate the value of the cost? So that's why it's the risk. So I'm not talking the problems, right? This part of this can think differently. You can think differently with respect to AML tools. That's what we are going to talk about. This here, there is a kill the compound. Kill the compound is very important. Kill the compound means just don't let the compound go to the stage. This should be our goal. There are actually things exclusively trying to kill the molecule. 80% of the 90% of the people are removing the molecule. People are working on that. There is a subject sector trying to find problem this molecule so that they can kill it. It will kill it, it will never. See, this is how the same company from the losses, right? It's not the case. Yes. So, because it's very risky, see, you can use the AML tools so that you can reduce the time and cost. You can improve clinical testing. You can have rediscovery much faster. You can also have efficient clinical trials as well. Every day. Initial implementation of AML was the trials. How we are going to use AML in the clinical trials? There is a stage. How many patients are participating in the trials? Who is going to handle all the bulk of the data? One person can have hundreds of parameters. Right? And we have thousands of people participating from different locations. Who is going to compare it and say that okay, expect that not the same side effects are happening. It is not really possible. But the way you can design can be much better use the AML. So people have questions started using AML tools for your trials. Not only that, whether your people side or not. For you to identify the human is present or not, you are using imaging techniques. One of the first things that AML was the imaging. By just taking the X-ray, they will be able to predict what kind of state the particular disease is. Right? Because it's not about imaging. It's not about comparing. Applying the mathematics to tell whether the disease condition is the adverse state and what are the state. You can also monitor how the treatment is changing its image structure. Right? It's not about taking the image and putting it to comparative analysis. Right? As I mentioned, everything can be applied. It's also filtered by bioinformatics, also by the pharmacokinetics. We have more than 10,000 proteins in our body and lakhs of genes in our body. How they are interacting with each other? It's a complex network structure that can be analyzed by bioinformatics. Again, bioinformatics can also handle AML. Right? Now we have omics data. Lot of genes, lot of proteins data, lot of metabolic data is complex data can be into patterns. And why I try to understand this because for me to understand how expected disease happen, I try to understand pathways that are there. You know, once you know that this is the pathway responsible for the disease, I can try to target special pathway, right? Once you know that insulin is the deficiency in the diabetes, we try to produce the bovine insulin product like recombinant insulin, right? Similarly, you can also have some other target identified, right? How do you define it? Based on the omics data, based on the bulk of the data, you try to understand the pathway and which are the pathways not. That's how you select the target. Selecting the right target is the best approach. You cannot just take any target and find down the target, right? If you just take any normal target, what happens? It's also, if you need the better target, it's also going to produce a lot of same issues. Correct or not? That's why always you have to take the right target. Even human, it is not possible for us to handle all the data. That's why we can say, right? Speed and efficiency can be increased. Cost reduction very much possible because we are going to reduce the number of molecules, not 10,000 molecules. Probably less than 100 to 50. Improve accuracy can be possible. Personalized medicine is always possible because you know once you incorporate all the individual patient genetic data into a computer, it's possible for us to know. You will not be able to remember human. A machine learning can be able to learn it, right? And statistical this is not so to take it. That's possible. These are some of the different AI tools I have now. Just one some example. I have my own different collaborators working in different fields, have their own tool of AI. It's not a rocket science, trust me. Three of my friends, and four of my friends having their own AI tools. They are now actually have their own startup journey. There is AI summit happening in New Delhi, right? I'm sure just check the progress. There also is a lot of discussion. There's a lot of discussion happening that is serving waste, right? It's not. This is BioAsia, conference happening by BioAsia. There are also even CMA, Telangana, so the theme of the conference was BioAsia conference was AML therapy. Everybody's talking AML. Why are we talking so much of AML? We don't have the AML part. They're going to miss the opportunity. Just going to pharmacy knowledge is not so. Don't be very comfortable zone of okay, I'll just go and work in some pharma. That arrives over. You can produce wonders if you know the pharma background, plus the language. Do things a rocket science can be done. Oh, I'm not by this, I'm not ambitious, I'm by this. I think that okay. If PhD programs in years, even biology and going to academic course, PhD, okay. Remove the barriers, learn the program. This is going to happen like in custom. You want to learn? Amen. If that is the job potential, you can perform much better than the software is. You can also have your own startup. You can also have your own innovation building. This is some of the examples of the areas. See, what is the center? You don't talk to the represent. What is represent? What is building design architecture? Right? Example. If building architecture is properly not done properly, done properly, right? The architecture is not done, construction is over, and it's about to move to the building. You have found a problem. What do the building? You have to understand. I have to go to the building, right? That's the case. We can actually, if you have money, you can have time and do it. What are the similar records? Before inside, before people testing, we can design such a way that it meets all the requirements. What are the requirements we are talking about? Safety, efficacy, affordability, sensibility, everything. Keep in mind, we can design a market and it's possible. But it's not possible. We have samples. We have tools. What is important? We need a raw existing data from the data. Okay, paracetamol. With this spectrum pathway, safer. With this spectrum pathway, it's toxic. We know drugs how safety are toxic. We also know how drugs bind to the targets. Based on that information, we are able to predict. Servers are generated, right? Generating not just static, it's much beyond. People are using tools within an molecules. Without any pharmacy background, people are trying to design the molecules, right? So I think the findings we have to go to the right, supplement to the findings. We have time to. I don't have time. I have a conversation to go on. That's why I have shape right now. We'll see. So what I'm saying is, designing level itself can be targeted. Okay. I don't want to start just like that. I optimize by using my tools. What are the tools I'm talking about? It's chemistry. It's binding to my center. It's physical properties. It's liquid flows. Everything I try to optimize. It's stability, metabolic stability. It's excitability. It's protein binding. Everything I try to optimize and design level. So that it is not creating any, at least at the design level, it's not any issues. I'm okay. Then I can go for testing. Right? So instead of 10,000 molecules, I can reduce to the lesser molecules. Just see how many companies are start working. If you just see one, see first one is ESA, right? Why ESA is so that it's a superpower. It's just that it put the course of population. And they don't produce the small bits, you know. Everything comes from outside. How can it innovation? Now they related. Okay, is the next era. That's why they are already investing a lot of funds every sector so that they're the first one to discover the drugs. Then they will just impose the cost on it. It's not the case. What are we doing? We are just okay, good, I got a new job. What job we are doing? We are just doing, cheap level job. We are not doing innovation. Yeah, now IT sector is also just serving. But the bank problem function, we are losing our super work for them, right? But then we have very quality medicine. We have all the GMP manufacturing units in different places that produce drugs and sending to you. And our new discovery happens. No new drug come to us directly, it will come only after 5 years when we do it now. Because it is related market for them. But the goal is how they reduce the cost, how they can enjoy it. This IPO, right? You have one with IPO. Cost of IPO, right? Are we having different version IPO? Why can we produce this? Just one IPO can be more than 50% of the United States economy, right? That is the power of the innovation, right? Similarly, also, if you have new drug, we can dictate. Just we will have just 5 drugs discovered. And we have all the scientists have IITs, they have IIScs, as well as so many pharmaceuticals. Out of the box thinking is honestly. Same thing, but if you don't plan, then I'm saying very, very good. A normal pharma background are trying to come up startups. Right? Also, people are working on different events, discoveries, right? So if people think differently. Okay, explore this option as well. Please stop the basics. Also, please enroll for the AML course. And then you please enroll for the AML courses. If it takes more attempts for you to get it, it's going to be a lot of opportunities. See, different companies have gone to human rights with AML as a tool. We are talking about the whole years. Now we have what's already going to do. That is, there are such stories. And you just see this side, roads by the Novartis, where Sanofi, these are the multinational pharma companies. And other side is small startup. There are a big pharma company can dictate more pharma world going to small startups because they have expertise of AML. That is what Texas collaborations happen. What is the collaboration happening? Big pharma companies are exploring small pharma, small startups, telling them can help us doing AML based discovery. Those victories, AML victory awards, multinational pharma companies, they also realize the importance of the having this AML tool. That's the problem. Why we should not learn this in this case? That's why, right? So if you Google also, it's all about the packet protein, right? So Google also you see alpha-fold is a Google protein structure prediction. Alpha-fold is a Google to have a protein structure. This is also getting included. And A is spectral screening. You don't actually do that screening. You can just screen the molecules whether they're active or not. Right? No need to censor the molecule. No need to have experiment, no need to put your reaction. Just how to compare simulation that we can tell that compound or not. It's fine. It's not fine. You can predict it. So that we can build some molecule screening done on the computer. So that we can avoid lot of times inside also. Even first also reduce. Structure based design. If you know the structure of you know the structure of your protein, you know the structure of your drug, you can able to design the molecule better. You know which structure is good, which structure is bad, which kind of side chain is skeletal side chain not but also you know based on that you can actually able to say if you know the structure of the previous year, etc. This binding site you can pull it around you. Okay, this amino acid, this hydrogen bond required, this much distance between from one hydrogen bond to other hydrogen bond. Lipids rules can do this and can design a molecule. That's what we call structure based drug design. Compared aided versus complete aided, which is more powerful. Aided is support. Preparing everything is developing only computer. Now everything is computer drug design. Or is some support of computer. Today, every support is taken from a computer. Computer driven. We are moving towards the computer driven. Obviously, right? Everything is computer driven nowadays. It's not narrow expression. Computer driven is happening every stage. And one government of computer driven state. Correct? State driven research. So just see this family simulations are one type. Just because a bioengineering which is produced by the Microsoft, they can do how many more than 10,000 to 1 lakh times speeder. 10,000, 1 lakh times speeder it can do the calculations. Because it's discovered by Microsoft. Why then? Why they have experts? Because Microsoft is that okay. There is a lot of potential for us to use exploring structures, this simulations in practice. This is what called bioengineering is tool of the Microsoft. You can also predict the safety of the drug, you can predict actual safety of the drug before actually success. So that no risk of the toxicity can be completely avoided. Beautiful, right? That's why it's designed, you can predict it. That's what's happening. Now this AI tools, what the target is before they get the second slide of our slide. Now we don't need 10,000 molecules. We just have, if we can design upgrade the molecules at very minute level, every detail, do you still need 10,000 molecules? Do you still need that much of time? I don't think so. We have seen the success stories of the molecules already done based on that means we can cut short the time. We can reduce the molecules from 10,000 to 100. Easy for us to study, easy for us to do the experimentation, and easy for us to pay the errors. You can also pay 100 molecules instead of 10,000 molecules, right? And you can also reduce the time from 2 to 6 years, maybe less than 1 year. So, why can't you say this 6 years? You can also save time here because you use AI and those things. That means it's possible for us to use AI and increase the discovery innovations. Why we should do more on this? Because India is lacking in innovation. A lot of funding opportunities as well. That's why we should become going of using AI tools to enable us the leader in the pharmaceutical innovations. I have a lot of content to cover. So this actually probably we learning to cover it. I'm sure they are also hungry. I would like to stop here. I would like to ask the questions we have done in direction. Thank you so much for the opportunity. Thank you for wonderful listening. Any questions you have, we can actually discuss. sorry, I have to express it because of the time and resilience. And also, I would like to thank my senior, experienced senior Vidya madam, and she was actually from the same college where I spent my now. And very, very happy to be here with us today. Thank you so much.
Very also present I would say but maybe we have to work more on it to see that how we can be more about a job. It's not small, we're saying that how we can motivate our students and young finally someone so that they can engage more and more in the research work.
So, I say, motivation is the only the way we can, otherwise, at least I can see people are attending to this to us, at least they are motivated. And one that I expect them to watch that mobile test, at least really appreciate this particular attention I have paid and gather, from other, participants like that. So, take success stories, small success stories, inspire them. Madam was also talking about don't look for job, even jobs. And it cannot happen without human constant effort. Don't think that no, we are not rich, we are not, my brain is not good. No, you don't need a great mind, you just need a strong motivation, constant, constant consideration to be possible. Keep on upskilling is listening to different topics, listening to different seminars. Content are in the Google. Lot of content on YouTube. Why not explore that? We are based on other social media. We are nothing, we are doing nothing like that. We can start speaking. We can also take membership of your pages as well as online courses there. Why can't enroll for them? NABT course are there. Enroll for them. And challenge yourself where we stand, right? I think that's what I can say. But it's very difficult for the students to read these scholars also. They have everything like that, still they want to stick to their family. They don't want to students. That is problem is they are not able to find the right student. They are not ready to take that steps, right? Thanks. From audience, no questions? Thank you so much, sir, for your insightful presentation. And once again, my heartfelt thanks to management, as a principal, secretary, for giving this opportunity. Thank you.
Thank you so much, sir. First and foremost, placement started to every resource person publication sir, for entering the core session. As a token of gratitude, we now request the dignitaries to kindly consider the honorable resource person Dr. G. Chandra sir. I request the assistant and principals to be kindly join, and now the HOD person also be kindly join the session. I request everyone to please give a big round of applause. Thank you so much, sir. A sincere thanks to our chairperson, Dr. T. Sailu, sir. Sir, your presence will add excitement to the session and we're truly grateful.
And request the chairman of the peace side to kindly accept program from our dignitaries.
Thank you so much, sir. We are especially thankful for our co-chairperson, team Manoj Prabhakar, sir, for presiding over the session and offering the valuable insights.
It's not gratitude because the English leadership or whole 8%. Team Manoj Prabhakar. Thank you, dignitaries, for such wonderful sessions. The students to please proceed for the lunch. After the lunch, we will be having